So let's move to addition rule in this video. Excuse me. What's happening? It's not moving. We'll move it this way. All right. So we are going to identify if two events are mutually exclusive and make a addition rule for two events. So, two events are mutually exclusive when they cannot happen at the same time. Which events we consider mutually exclusive? For example, day and night. God forbid if day and night exist at the same time, right? It will be end of the world. Also, what else cannot be at the same time? I don't know. I don't come up with any other idea at the same time. I'm out of creativity. Shortly sake, two events that cannot exist at the same time we call mutually exclusive, and this one is mutually exclusive. They are separated. They don't have anything in common. But not mutually exclusive. There are millions of events that mutually are not exclusive. Let's say what it can be. It can be sun and wind, right? It can be rain and sun. It can be female and engineer, right? They are not mutually exclusive. So, mutually exclusive event. Decide if the events are mutually exclusive. Event A, roll a 3 on a die and roll a 4 on a die. I have to say, when first time I saw this slide, I got confused. I thought there are two dice. It's talking about one die only. So can one die be 3 or 4 at the same time? Of course not. They are mutually exclusive. Another one. Are these events mutually exclusive? Randomly select a male student and he is a nursing major. Well, 10 years ago that could be a mutually exclusive case, but nowadays it's not a mutually exclusive anymore, right? So, rule of the addition. When we are talking about this event or that event. In that case, we replace this or with addition. I'll tell you a little bit later what means minus here, A and B. With a little bit patience, I'll make it crystal clear for you. This is for not mutually exclusive, this formula. This one is for mutually exclusive. So let's solve some examples so we can make things understandable. We select a card from a standard deck. Find the probability that card is a 4 or an ace. So what's the probability if the card is a 4? How many 4 we have there? 4 of them, right? 4 out of 52. How many aces are in the deck? Again, 4 of them. 4 out of 52. Because it says 4 or an ace, so we connect them with addition. And it will be 8 out of 52. Here it is. 4 out of 52. 4 out of 52, and you get 8 out of 52, 0.8 154, which will be 15.4% chance that you will pull the card and it will be 4 or an ace. Okay? Next, find the probability of rolling a number that is less than 3, a number, let's say x, that is less than 3, or rolling probability of odd numbers. Okay, what are numbers that if you roll a die will be less than 3? It's going to be 1 and 2, right? Let me do a little bit change here. Instead of less than 3, I'm going to put less than 5. So I'm going to change a little bit conditions. I want to make it more interesting. Less than 5. It's going to be 1, 2, 3, 4, 4. Okay, 5 is not included because equal sign is missing. Now it's asking odd numbers. What are our odd numbers? Odd numbers are going to be 2, 4, and 6, right? All right, so because we have OR, so how many we have probability for x is less than 5? 4 of them. 4 out of what? 4 out of 6, correct? Okay, what is the probability? So, 1 second. Probability x less than 5 or odd. So 4 out of 6, a probability of odd numbers. There are 1, 2, 3 of them, right? 3 out of 6, correct? But here is interesting thing we have. If you look, number 2 is repeating, duplicating. Number 4 is duplicating, correct? Which means result is not going to be correct because we have 2 and 4 duplicated. 2 elements are duplicating themselves and in this probability and in this probability. So we need to eliminate the duplicate. So since there are 2 elements that are repeating themselves in both cases, we need to subtract these 2 elements minus 2 elements out of 6. And this is the case. Remember when I said if you wait, you will understand in the formula what that means. Let me go back. This event. See, minus probability A and B. This is the one when you subtract minus probability of A and B when they overlap each other. They repeat themselves and in the event of A and in the event of B. Okay? All right. Let's go back now. So minus 2 over 6 and result is going to be, let me open it because we have it here, 2 over 6 plus 3 over 6. In this case we have minus 1 because I did change it, right? So we get, let me rewrite it. So 4 over 6 plus 3 over 6 minus 2 over 6. That will be 4 plus, since denominator is the same, I can operate with numerator. 4 plus 3 is 7. 7 minus 2 is 5 over 6 probability will be. Okay. Now, moving to next one. I'm not touching this because I did some changes, right? I made it more interesting. Here was only 1 element overlapping. I made 2 overlapping so you can clearly see how to deal with them. Okay, using addition rules, So the frequency distribution, this is a sales volume here, okay, in dollars. So it's asking if the sale pattern continues, what is the probability that the sales representative will sell between 75,000 and 124,999 next month? So what will be the probability? How many months it took them to make that much sale? So from 75,000 to 99,999, it took them 7 months. From 100,000, 124,999 took them 9 months. So together it made 16 months, right? Out of how many total? If you add all these months together, let's see. Total is going to be 36. If you add all of them up, it's going to be 36. So 16 over 36, it's going to be 0.4444, which is approximately will be 44.4%. Okay? 44.4%. So that's pretty much it, this one. Moving to next problem. A blood bank catalogs the type of blood, including positive and negative Rh factor, given by donors during the last 5 days. A donor is selected at random. Find the probability the donor has type O or type A. So what's the probability for type O? Total, we have how many types O? 184. Out of how many? 409. How many we have types A? 164. Out of how many? 409. So probability for O or A type is going to be, wait a minute, did we move ahead? $184 out of 409 plus 164 out of 409. We get 348 out of 409, and the percentage-wise, it will be 85.1%. Okay. Let's solve another one. Find the probability that donor has type B of blood and Rh negative. So what is interesting here? Type B comes this way. Rh negative comes this way. Which means this 8 is going to overlap, right, in the probability with type B and Rh negative. So which means we're going to do the following. Probability of type B is total 45. Oops. 45 out of 409, right? Probability of Rh negative is going to be 65 out of 409. And because this 8 we had and in type B and in Rh negative, therefore we subtract to eliminate duplicate 8 over 409. And the result will be 102 over 409, which is approximately 0.245 or 24.9%. 2 positions, meaning multiplying by 100. I hope you are doing good. And we are done with section 3.3. See you in next section.